10-5, writing piecewise functions. Don't you love math? First you add, then you learn how to subtract. First you multiply, then you learn how to divide. First you were given equations and you had to graph. So of course we're going to be given graphs, and now we have to do equations. Do these systematically. Work from left to right. Also, they identify the equations and then the domains. I don't. I do the domains first. Okay? And I can flip back and forth. So, left segment domain is going from -6 to 3, or -6. Oh, say it and don't write it. -6 to -3. And it's less than, x is less than, but this is a closed dot, so he gets an underline. Okay, middle goes from -3 to 4. Domain, less than and less than. Closed dot gets an underline. Open dot, he's fine. Next one goes from 4 to 8. Oops, sorry, from 4 to 8. Less than, less than. They're both open dots, so no underlines. Okay. The left segment. Slope is 1. If I kept going, it would be at, the y-intercept would be 7, so it's y equals x plus 7. Horizontal line at 2. Horizontal is y equals 2. Right has a negative slope, and it has a slope of 2. And so if I went and so I would have to take, I'm just going to take the point 4, 6, y equals -2x at 4, 6. I'm going to use point slope, and so I have this point 4, 6. I'm going to use point slope. I'm going to have y minus 6 equals -2x plus 8, bringing over, that's a 14. So then I'm going to take these three equations with these three domains. F of x with this big old squiggle is x plus 7 with a space over. -6 is less than, x is less than -3, sorry, less than or equal to. And then I have 2 from -3, and then I have -2x plus 14 from 4 to 8. And that's your final answer. So this is your process. I do the domains and ranges. I do the domains first, and then I create my equations. Okay, here we go. I was doing something else on here. Sorry, I was doing something before I made the video. Okay, you should recognize this is an absolute value equation. You also need to recognize that absolute value equations have 2 lines, and it becomes a piecewise. And so I'm going to identify the vertex, and it is 1. It is at 4, 6. Now, this has nothing to do with the absolute value, other than that you need to know that it has 2 pieces to it, and piecewise functions go, every line segment is a different piece. So I'm going to go here, and this is a turnaround point, or a pivot point, and so this part of the graph is at x is less than or equal to 4. And this part of the graph is x is greater than 4. So this is it's a line, and we know that right now absolute value, they're doing absolute value functions. They have not opened and closed them, and so this is at x plus 2, and the next one is at negative x, and if you continued this up, it would hit at 10. Here, this one is from negative 6. So x is less than negative 6. That's how you get this. It has a ray, so it's this way. And then we have x is greater than or equal to negative 6. That's a whole, so it didn't have an underline. That had color, so it has an underline. This piece is, the slope is down to, up to right 1. So that is 2x, up to right 1. Got to keep following it. That's at 8. And then this one is also 2x plus, and if I follow this one, that's at 10. Every time you make a turn, you must have another equation. So I'm going to have an equation, an equation, an equation. I have a segment, a ray. This segment goes from negative 3 negative 8. It's a horizontal line. It had a closed dot, and the equation is y equals negative 2, and that's y equals negative 2. I then have from negative 3 to 3. Touches and touches, and my equation is going up 1, 2, 3, 4, 1, 2, 3, 4/3 x plus 2, and then I have a horizontal line at 6, and it goes from 3 to, it goes greater than, sorry, messed that one up. Because it's a ray, you have to do x is greater than or equal to 3. Okay, next one. A piece, a piece, a piece. So this one goes from negative 9 to negative 5. It has closed dots. This one goes from negative 5 to positive 3. And it has closed dots. And this one goes from 3 to 8, and it has underlines. Sorry, didn't show you that. Okay, I'm going to use this point right here, which is -5, -4, and I'm going to go 1, 2, 3, 1, 2, 3, 4. So my slope is 3/4. And I'm going to do point slope. Y plus 4 equals 3/4 x plus 5. Y plus 4 equals 3/4 x plus 15/4. Subtract 4, which is 16/4. So I have 3/4 x minus 1/4. So this is actually shown work. Should have shoved it up a little bit farther. Okay, so this one goes with that one. Okay, here I'm still going to use -5/4. So I'm going to use -5/4. I'm going to use 1 down, 2 right, -1/2. So y, -5/4, plus 4 equals -1/2 x plus 5. So I have y plus 4 equals -1/2 x minus 10 over 5/2, sorry, 5/2. 8 halves, 8 halves, so I'm adding 8 halves, subtracting 8 halves from that side, which is -13 halves, so this is -1/2 x minus 13 halves. Got that one. And this one would be, this point is 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. -8, which would be 3, -8. And I'm going up 2, 1, 2, 3, 4, 5. So that's 2/5 x. And so I have y plus 8 equals 2/5 times x minus 3 equals 2/5 x minus 6/5. That's 40/5. That's 46/5. 2/5 x minus 46/5. So that's minus 46/5. So this is your answer for that graph. All right, last one on this example. Okay, left to right, that's a ray. It is going x is less than or equal, less than, not equal. It's got an open dot, less than -2. I have something that's a ray that is x is greater than -2. And then I have this dot which is at -2. And because I have a closed dot on top of 2 open dots, it still remains a fraction. So this right here is at, let's see the slope. The slope is -5/3, and this point is at -2, 3. So this